Hello everyone. Today, I'd like to explain a bit about the chain rule, or the differentiation of composite functions. If you try to prove this rule using equations, it can look quite complicated, but I think you'll find it incredibly simple when explained visually using diagrams. To explain this visually, let's consider a tangent line in the direction of a curve in a 3D graph. While many tangent lines can be drawn for a single point in 3D, let's focus on the one specific tangent line that lies in the direction the 3D curve is advancing. If we think about it this way, I believe you will instantly understand why the rule is the derivative of the inner function multiplied by the derivative of the outer function. First, let's look at the z-plane. The curve here is essentially y equals 1/2 x squared. When viewed from the z-plane, it looks like a curve with a tangent line. The width is about 3.5 and the height is 2.6. Next, let's view it from the y-plane. The curve in the y-plane is z equals 2y squared. We can rewrite this as z equals f of y, which equals f of g of x. The tangent line we saw earlier now appears to have a width of about 5.2 and a height of 6.0. Finally, let's view it from the xz plane. The equation is z equals 2y squared. If we substitute 1/2 x squared for y, the equation becomes 2 times 1/2 x squared squared. This is the composite function, z equals f of y, which equals f of g of x. The tangent point here has a width of about 6.0 and a height of about 5.2. Now, let's look at the relationship between the slopes, gradients, of the lines between these planes. The slope we want most is on the xz plane. The slope is 5.2 divided by 6.0, which equals 0.867. Then, let's multiply the slopes from the z-plane and the y-plane. The calculation is 2.6 divided by 3.5 multiplied by 6.0 divided by 5.2, which equals 0.857. Since the diagrams were drawn freehand, there's a slight error, but we can say these values are essentially equal. So, what does this show? First, the slope on the z-plane represents dy dx, which is g' of x, or the inner part of the derivative. Next, the slope in the y-plane represents dz dy, which is f' of y, or the outer part of the derivative. The remaining slope in the xz plane represents dz dx, or z'. Since the overall slope, z', is equal to the product of the intermediate slopes, g' times f', this confirms the chain rule: the derivative of a composite function is the derivative of the inner function multiplied by the derivative of the outer function. The numerical values were a bit complex, so let me explain further. Ultimately, we are thinking about the tangent line that touches a 3D curve. The direction of this tangent line is the exact direction the curve is attempting to advance or increase. Thus, thinking about the tangent line is simplified to analyzing what happens to a straight line within a box. Let's consider a cuboid where the side lengths are x equals 1, y equals 2, and z equals 4. First, look at the z-plane. For x equals 1, y increases by a ratio of 2. The slope is 2. This means the derivative of y with respect to x is 2. Next, look at the y-plane. For y equals 2, z increases by 4. The slope is 2. This means the derivative of z with respect to y is 2. Since z is a function of y, and y is a function of x, when we look from x to z, x increases by 1, and z increases by 4. This means the derivative dz dx is 4. Essentially, y is 2 times x, and z is 2 times y. Therefore, when viewed from x, z is 2 times 2, which is 4 times x. The slope represents the multiplication factor, dy dx is the factor from x to y, and dz dy is the factor from y to z. Multiplying these two factors gives the overall multiplication factor, dz dx. This overall factor is the value of the composite function's derivative. In summary, when differentiating a composite function, if you consider the composite function as a curve z equals f of y and y equals g of x in xyz space, the slope of the tangent line seen from the z-plane is the inner derivative, and the slope seen from the y-plane is the outer derivative. By understanding this, you can see the meaning of multiplying these two slopes together. That's all for this time. I apologize if the latter half was difficult to understand due to all the talking. I hope it was helpful. Please keep watching. Thank you, and see you next time.